Hi guys, we're going to solve absolute value equations. And these are equations that will look like this. So we have some quantity inside absolute value bars and it equals some number. And when we get an equation like this, it can get split into two separate scenarios and we have to solve both. So if this absolute value is equal to a positive number, so if it's greater than 0, we're going to take this equation, and to get rid of the absolute value bars, it gets split into two different equations. Because for the absolute value of this quantity to be C, the inside has to equal C or the inside has to equal negative C. Because the absolute value of C is C, but also the absolute value of negative C is C. So we take this inside, this AX plus B, and we can write an equation saying it equals positive C, and we write a separate equation saying this equals negative C. Now, in order to split into the two different equations, we have to have the absolute value completely by itself. So in this first one, this absolute value is completely by itself, and we have this 2x minus 5, the absolute value of this equals 35. Well, that means what was inside here had to equal 35, or what was inside here needed to equal negative 35. So I'm going to get rid of these absolute value bars, I'm splitting this into two separate equations. The inside, that 2x minus 5, had to equal 35, or the inside, that 2x minus 5, had to equal negative 35, right? Because again, the absolute value of 35 is 35, and the absolute value of negative 35 is also 35. So it could have been equal to both of these things. So since it could equal both of those things, we have these two separate equations that we need to solve. And what's kind of cool is it takes the same steps. So I'm thinking about my socks and my shoes, and I'm going to take off the sock first. And so for both of these, it's adding 5. And you don't have to solve these at the same time, but I kind of like to because we're doing the same thing. So I'm going to add 5 to all the sides. Then I get my new equation. This is just 2x equals 40. And then I have to be really careful that I am thinking about these separately because now they change, right? This is going to be 2x equals, I have negative 35 plus 5 is negative 30. Then both sides are going to get divided by 2. I'm going to do that on all the sides. And this equation solves to x equals 20. And this one is x equals negative 15. So we have two possible solutions. It's negative 15 or it's 20. And I can write my answer as a solution set. So my solution set, I do a little brace and I list my solutions from least to greatest. So negative 15 is the smaller solution, 20 is the larger one. So there is my solution set. Now, before I can split an absolute value into two equations, as I said before, it has to be by itself. And so we look at this one. I have a 3 on the outside. I cannot split this into the two equations into an absolute value. You cannot do that. Those are like castle walls. It's blocking everything out. So I cannot distribute that 3. I have to get rid of it first. So I'm going to need to get this x plus 2 by itself. So the opposite of multiplying by 3 is dividing by 3. So I'm going to divide both sides of this equation by 3. And now I have this absolute value by itself. I have that x plus 2 equals, and 27 divided by 3 is 9. Now that the absolute value is kind of isolated, it's the only thing there, now I can split it into the two scenarios because what was inside here for the absolute value to equal 9, this whole thing had to equal 9, or this whole thing had to equal negative 9. So I'm going to split into my two equations, and my two new equations, is the x plus 2, so that inside part could have equaled positive 9, or the x plus 2 could have equaled negative 9. And now I can solve those simultaneously. And for both of them, I just need to subtract 2 from either side. So I'm going to subtract 2 from either side, being mindful that my answer will be different. So this turns into x equals 7, and this one is x equals negative 11. Those are both solutions. So I can write my solution set. I'll use my braces, and the smaller one goes first. So negative 11, and then my 7. Okay. So now I see this example C. And again, I cannot split this into 2 right away because this is not by itself. It's got a plus 3 on it. And so I'm going to subtract 3 to start off with. And then my new equation is this absolute value of x plus 7 equals 0. Now, this is a special case because before I was like splitting this into like 2 scenarios, like it could have been positive or negative inside, but there's no such thing as positive or negative 0. I'm not going to write x plus 7 equals positive 0 and x plus 7 equals negative 0. This is a scenario where there's only going to be one answer. So at the top here, it does say if C equals 0, then there's only one solution. There's only one equation I'm going to have to solve for the absolute value to be equal to 0. Then the inside must have had to be equal to 0. So there's only one equation this time. It doesn't get split into 2. This is just going to be x plus 7 has to have equaled 0 for its absolute value to be 0. And then when I solve that equation, I get that x equals negative 7. So, right, my solution set, if I wrote a solution set, it would just have one number in it, negative 7. Okay. Last one. I don't actually have to do anything. The definition of absolute value says that it's a number's distance from 0, and that distance is always positive, right? These bars always made our answer positive. So could the absolute value of something ever equal a negative number? No. So I see this, and I automatically know there's no solution to this. No solution, because absolute value cannot be negative. And so it does say up here, if C is less than 0, and maybe I'll put a note here, like meaning if C is negative, then there's no solution. So no solution. And if I was to write that in set notation, I would put this symbol, kind of like an O with a slash through it or a 0 with a slash through it, and it means empty set. It means there are no numbers in the solution set. There is no number I could plug into for x and have the absolute value be a negative. Absolute value cannot be negative. Okay. So go ahead and try these ones on your own and see how you do.